Hello everyone, this is Shumit Pro. My ID is 1810154 and this is about CSE461 group now 5, and this project is about the line follower robot in Uyghurs. So at first I created a new project from the new project directory, and I took the texture background from the objects, and from that object also I took the texture background light. So in here I took the texture background from the objects, and from the backgrounds I also took the texture background light, and for the floor I took the built-in floor as there is rectangular arena, and from the floor I basically choose the floor tile size, and in the wall thickness and wall width I took as it is. And then for building the robot, I basically took the robot from the objects, and in the base nodes I took the robot this. And after taking the robots, I made it translation, rotation, and scaling. But before that, I basically took the body shape, and for taking the body shape, I basically jump in the chain children and take the objects from here. And from this objects, I basically take the shape for our body. And then after taking it, I took the appearance as PBR appearance. I took the geometry, and in this geometry, I also choose the objects as box. Then I took its name as body, and in the bounded objects, I make it the use of body. And then I actually click on the physics and took the physics from here. After that, after taking the body shape, I basically choose the translations of it, rotations of it, and scaling. So as it's in the four pointer as the body, then I took the four wheels. For taking the wheels, I basically once again gone to the children. Then I took the objects here, and from the objects, I basically took the hinge joint. After taking the hinge joint, I basically take the joint parameters as the hinge joint parameters. Then in the device, I took the rotational motor, and in the endpoint solid, I basically took the children once again and take the shape as our wheel. So I took it the name as wheel shape, and then in the appearance, just like the same, I took the PBR appearance, and in the geometry, I took the object as cylinder. So in the cylinder, after that, I took the bounding object as a wheel using the wheel shape, and then took the physics. And just like that, I also did the other three wheels too. But the difference between the four wheels is about the translation and about the rotation and the scale. I made a change on the wheels as upon on their rotating motors as the translation rotation. So this is all about the wheels. And then if I talk about the sensors, I also went for the children, and in the objects I take the distance sensor here. So from the distance sensor, I basically took the sensor and then name it as the right sensor for the right sector, left sensor for the left sector, and the mid sensor for actually tracking the track. So after taking the sensor, I actually translate it as the right sector, rotate it, then rotate it as the right, so that it works on the right to keeping the track as right, so that the robot can move on to the right in the track. And then I keep the boundary object and physics as now. Then in the here, I actually take the type as infrared sensor, so that it actually works as infrared sensor. Just like this same way, I actually took the left and keep the type as infrared, and the mid sensor basically I took the sensor as infrared too, and the works and the translation, the changes remains the same as the way it works as mid, the way it works as right, and the way it works left. So thank you, that's all from me.
Hello, this is Sabia Afrin and I will show how we have created the track for the robot to follow the lines. At first we have to go to Autodesk Track Tinkercad and create new disk, and we will choose the option scribble to create a random track line like this, and then we will save it. We have to set the height to 0 and we will give it a random color, and then we have to export the file in OBJ format. Then we have to go Then we have to go to the file option and import 3D model. We have to choose the location. We will choose the Tinker file. Next, next, and finish. The track is actually huge in size at first, so we have to adjust. This is the track so we have to adjust the scale and everything. So we will have 0.04, and we will copy this for all the three values. You can see the track is much shorter. Then we have to also adjust the translation and other values as well. And after, it will take some time to adjust it with to touch exactly to the ground. So after the adjustment, we will have this perfect um, track line, and the robot will be perfectly following the track line. Thank you.
Hello everyone, this is Mahfuz Hossain and I'll be describing the coding part of our project. So at first we have created an instance of the robot, then we set the time step 32 milliseconds and the max speed of 6.28. So the robot will get readings from the sensors every 32 milliseconds. And here we have initialized four motors using the get device functions. Then we have set the position of the motors to infinity and the initial velocity set as 0. And we have connected IR sensors by using get device function, and IR sensors are named as right sensor, mid sensor, and left sensor. And right and left sensor will read data outside of the line, and mid sensor will read the data in between the line. And now we run a while loop, and at first we have got the values from the sensors, and set the right speed as max speed and the left speed as max speed. And now Noreen will describe rest of the part.
Hello, this is Noreen Tasnim Moon. I will simulate the robot here. Now we have added 3 distance sensors with a type of infrared in our robot body. At first, drag the robot towards the line and align it with the line. Now we have to check whether the sensors are in correct position or not. The left and right sensor should detect the floor and mid sensor should be on the line. Now this is perfectly correct. This is clearly perfect, and now going to the controller code, we have already set the IR values in while loop and set the right speed and left speed to max speed. Now in the processing data, we have to calculate the values so that the robot can detect the floor and line to follow. Here we have set codes to move forward, take left turn and right turn. After simulate it, we get something like this, where robot was not following the track, and so we need to calibrate the values. So in the processing data, after calibrating all the values, we set the IR value to 350 as we have simulated before. So in the console we can see that the left IR value is 380 and right IR value is almost 800. So the values fall between almost 300 to 800, and the mid value is 367. That's why we have set the IR threshold to 350. When left and IR value is greater than 350 and mid IR value is less than 350, that means both our right and IR touching the floor and maximum light is reflecting in the middle, hence both motor will start rotating. Then we have checked if the left IR value and right IR value is greater than the IR value and mid IR value is greater than the IR value. Then it will turn left with the by making the right wheel speed in the right speed and decrease the left wheel speed. After that, we have checked the left IR value is greater than the IR value and right IR value less than, and mid IR value is also greater than or equal. Then we have to turn right. At that, for making the right turn, we have set the left speed to the left speed and decrease the right speed. At the similar way, we have each condition will follow some pattern, and that's how the robot will maintain the path. After simulation, it will run like this, that the robot is clearly maintaining the path we have made to follow for the robot. Thank you so much. This was our line follower robot.